Hello everyone. Thanks for the VOTSt 2024 committee and the organizers. I'm Jiawen Zhu from IIU Lab of Dalian University of Technology. I'm honored to be here to present our participating tracker, our VOTst, which wins the challenge of tracking objects undergoing topological transformations in the competition. Previous video object segmentation task aims to track and segment all the given objects in the video. The objects may deform, but do not change topology. As a new task introduced recently, VOTst addresses tracking by segmentation of objects that undergo topological transformations such as vegetables cut into pieces. It introduces new edges and expands the slice of life of an object. Video object tracking scenarios commonly contains multiple targets. Previous VOT or VOS approaches individually track each single object and ensemble all the single object results, which is inefficient. A OT proposes to associate all the objects at once. It embeds, matches, propagates, and decodes all the objects formally in a single passive network. The predictions are generated frame by frame in an autoregressive manner. As to core components, identity assignment mechanism transfers the multi-object mask into an learnable identification embedding by randomly assigning identities to each object. LSTT blocks introduce long-term attention and short-term attention for matching and propagation. Our MEM is one of the best trackers in open source until the VOTS challenge, so we choose it as our powerful baseline. Instead of expanding memory banks to accommodate extensive historical information, our MEM restricts the memory banks to a limited number of essential frames. This strategy balances the importance and freshness of frames to maintain an informative MEM. Additionally, temporal positional embedding is introduced to explicitly capture the ordering of memory features. At the beginning of the competition, for the new challenge of VOTSt 2024, we first investigate the performance of two best trackers in VOTS 2023 competition. As we can see, HQ track only obtains a quality score of 0.324 and the VOTS 2023 winner tracker DME only obtains a quality score of 0.358, which indicates that conventional VOTS approaches cannot generalize well to new challenge of tracking and segmentation objects with topological transformations. Additionally, we remove the post-process of SAM model in HQ track and find the quality score instead slightly improved. This may be that SAM can accurately segmentation various objects, but cannot preferably understand the objects with transformations especially turned into pieces. After training on trained split of VOTst dataset, DMAOT achieves improvements by a large margin. We also test the newly published MEM tracker on VOTSt 2024 validation set, benefited from the restricted memory bank mechanism. Our MEM demonstrates its advantages in handling tracking and segmentation object with large transformations and easily surpasses the tuned DMAOT, obtains a quality score of 0.484. After tuning the test hyperparameters, the quality score improved to 0.501. We further visualize and analysis the failure cases of our MEM. We observe that the results predicted by our MEM is not robust and stable, especially in the later part of the sequences. The tracker sometimes cannot recognize the target object or incorrectly segment the objects with different IDs. To enhance the robust and stability of our MEM, we propose a multiple trackers assemble strategy. The tracking difficulty usually increases when the targets have larger transformations along the time dimension. Thus, our MEM usually obtains more promising predictions at the beginning of the video than the terminal. We initialize 3 trackers at the first 3 of a video. They share the same model weights and have independent memory banks. Our main tracker is initialized by ground truth mask 0 and generates the mask 1 and mask 2 at the second and third frames for tracker B and tracker C initialization. From frame 2 on, we calculate the IOU scores between tracker A and tracker B, tracker A and tracker C, tracker B and tracker C. If tracker B and tracker C predict similar results with tracker A, we adopt the prediction result of tracker A. If tracker B or tracker C predict different results with tracker A, and tracker B and tracker C show more similarity than with tracker A, we choose the prediction mask by tracker B or tracker C as the final results. In this way, our tracker obtains a more stabilized prediction and avoids some shifting and object missing cases. At last, we achieve remarkable results on the VOTSt2024 validation set. Obtain a quality score of 0.544 on test set, and rank first in VOTSt2024 competition. Here we select a challenging video and compare the prediction results from our MEM and our MEM-OT. As we can see, our MEM-OT can stably track and segment objects with large transformations, occlusions, and similar target interference. At last, we conclude that directly adopting high-performance VOTS trackers for the VOTSt task can lead to a significant decline in performance because they have not been trained to understand the complex topological transformations of the targets. Fine-tuning on a specialized VOST dataset can improve this situation. Furthermore, superiority of our MEM approach highlights the importance of memory features, and the challenge of selecting suitable memory for complex object tracking with topological transformations remains an open question. Accurately understanding the complex topological transformations of targets in the real world requires extensive knowledge and a large-scale training dataset. Or, introducing multimodal LLMs may enhance trackers' ability to comprehend targets and their evolving topological appearances within dynamic spatiotemporal dimensions. That's all. Thanks for watching and listening, and thanks again for the VOTS 2024 organizers and all the participants.